Hey everyone, welcome to our first video here on cost, volume, profit analysis. I wanted to get us started with this first video just by recapping what we talked about last time with this contribution margin example for Lewis and Tom. So remember, we said that Lewis and Tom here, they manufactured this device that allows users to take this closer look at icebergs from a ship, and it gave us the selling price, the variable costs, as well as the fixed costs, what they generally are, over the course of a year. So we were tasked at the end of last class to figure out what the break-even point for Lewis and Tom would be. Remember, break-even point, that's just that unique sales level that we have to have in order for our income to equal zero. That means revenues equals expenses. All right, so let me hop out of PowerPoint real quick. Just hop over here to Excel. All right, so again, for Lewis and Tom, looking at our inputs for this problem, I'm going to use this formula approach to figure it out real quick. So from this formula approach, remember our sales price was 100. So we said 100x minus our variable costs were 70. So 70x minus $90,000 in fixed costs equals our income of 0. All right, so we did some maneuvering within our equation. I combined my like terms. I have 30x equal to, I add 90,000 to each side. So I have 30x equal to 90,000. I divide by 30, on each side, and I'm left with x equals 3,000 units. Remember, we said also that you could take this number, this 3,000 units, and you could figure it out in dollars as well. So 3,000 units times our selling price of $100 gives us $300,000 as our break-even sales. All right, so that's what our answer was for Lewis and Tom there. All right, so our break-even point, one more time, so just expand this out a little bit, sorry. Our break-even point was 3,000 units, or it was $300,000. Let's make that a dollar value. Oops, sorry, make this one a dollar real quick. There we go. So 3,000 units, or $300,000 was our break-even. I just want to save those up here because we're going to use those as we progress forward, looking at some more stuff here with cost, volume, profit analysis. All right, so let me hop back over here to my PowerPoint slides now that we remember what that looks like. All right, the reason that I like to use that equation approach is because it does have so many applications, and it's nice and easy to check your answer with any of these applications that you have, because remember, you can always just substitute back in for x, whatever your answer is, and see if it actually does equal what you said the equation was. All right, so one application is what we call this various sales level example. All right, so with various sales level example, the question that we'll ask ourselves is, what operating income is expected if we sell, fill in the blank here, however many units that we want to sell. If we're using this equation approach, it's nice and easy because all we have to do is substitute however many units we fill in this blank with right in for x. So if we were expecting to sell 5,000 units, for instance, well, we could figure out how much income we expect if we're selling 5,000 units. Just take 100 times 5,000 minus 70 times 5,000 minus $90,000. Remember, those fixed costs are constant, and we could figure out how much our income is expected at that sales level. And we could do that with whatever sales level that we wanted to look at. Again, one of the benefits of using that equation approach. We'll also look at what we call our target operating income example. With this one, what we say is just suppose that our business would be content with operating income of, again, fill in the blank. All right, so let me hop back over here. I'll show you this example over here in Excel. So let's say that Lewis and Tom, they're not content with breaking even. All right, instead, they want to make sure that they're earning operating income of, let's say, $600,000. All right, so if they want operating income of $600,000, that's cool. We can still use our equation approach to figure it out. My selling price hasn't changed, so I still have 100x. My variable costs haven't changed, so I still have 70x. My fixed costs haven't changed, so I still have 90,000. All right, my only difference now is instead of setting this target income equal to 0, I want to set this target income equal to whatever I want, or my desired operating income, which I said was 600,000. All right, well, now I just solve the equation again. All right, so I combine my x's. I'm still left with 30x. I want to add 90,000 to each side to remove it from this left side of the equation. So I'm left with 30x equals 690,000. All right, I can do some quick math. I'll do it over here real quick. 690,000 divided by 30. tells me that I need to produce and sell, there we go, 23,000 units to be able to break even. Again, if I wanted to take it a step further, I could multiply those 23,000 units times the selling price of 100, and that tells me in order to get there, I'd have to have $300,000 in sales. $2,300,000 in sales to get there. All right, so that is, one more time, that is just how we use this equation approach to figure out this target operating income example. All right, sorry, so let me kill that, get rid of that. And again, we could set that equation equal to whatever it is that we wanted to figure out, and we could figure out how much income we'd expect at that level, or sorry, how many units we'd have to sell to get to that income amount. Alright, objective 4 here wants us to use what we call sensitivity analysis. So use the CVP method to perform sensitivity analysis. Sensitivity analysis simply just means, how does my break-even change if one of these inputs within this equation change? Alright, so if our selling price changes, if our variable costs change, if our fixed costs change, how does that impact break-even? And that's what sensitivity analysis is. It's pretty simple. Alright, so let's say we, again, change sales price. We could change any inputs from this equation and figure this thing out. All right, so it says suppose that selling price per device is blank rather than blank. All right, we can fill in the blanks with whatever it is that we wanted. All right, so let me hop back here to Excel. Again, I'll just use Lewis and Tom again. All right, so let's say the demand for these devices to look at an iceberg from a ship has taken off, right? And instead of selling these devices for $100 each, we're actually able to sell them for $125 each. We're able to mark up that selling price by 25%. All right, that's cool. I could still figure this out. I could perform what I call my sensitivity analysis just by creating this new equation right here. Alright, so the only thing that changed was my selling price per unit to 125. So I have 125x minus 70x minus 90,000 equals 0. Alright, so I can do my math here. 125 minus 70 leaves me with 55x over here on this side. Add 90,000 to each side, so I have 55x, equals 90,000. Alright, I can divide those two numbers out. So 90,000 divided by 55 tells me, got a kind of rough number over there, 1,000. Sorry, I didn't work through these numbers before I provided them for this example. All right, so in order to break even, I'd have to sell 1,600, and I'm going to teach you a trick here. I'd actually have to sell 1,637 units to break even. All right, make sure if you ever get a decimal when you're working with your number of units, you always round up. Even if it's 0.001, you still round up. The reason is if I round down, if I said I have to sell 1,636 to break even, I wouldn't break even. I'd end up with a net loss if I only sold 1,636. So in order to break even, in order to make sure that my revenues are at least equal to my expenses, I have to sell that extra unit. I have to sell 1,637 units. Now that doesn't give me the true break-even point because my income isn't equal to 0, but it's better to be a little bit over than a little bit under. Alright, so anytime you're working with units, if you get to a number that has a decimal, always round that decimal up. Alright, so that's one sensitivity analysis, right? I could keep navigating back to the PowerPoint slides, but I know what it's going to be next. Alright, so what happens if instead of the selling price changes, the variable cost changes? Alright, so let's say one of our vendors that we purchase parts from to make these devices starts charging us a fuel expense, and it increases our variable cost per unit by $2. Alright, so instead of $70 in variable cost per unit, we actually have to pay $72 in variable cost per unit. Okay, I could still figure this thing out. 100x minus 72x minus 90,000 equals 0. Alright, so I can combine my x's. I'm left with 28x equals 90,000 when I add it to the other side there. Alright, so I'm just going to do that math over here. 90,000 divided by 28 gives me 3,214.2. Alright, remember what we said here. Always round up, so 3,215 units in order to be able to break even now. So because I had just that small increase, $2 increase in variable costs, check out what happened to my break-even point. It went from 3,000 units all the way up to 3,215 units. So I have to sell an additional 215 units to be able to break even in order, just because that variable cost went up by just that $2 right there. All right, we can look at one more example. All right, let's say my fixed costs increased. All right, let's say the facility I was using in order to manufacture these products was no good, and I had to upgrade to a newer facility, and it's going to cost me an additional $30,000 in fixed costs. That's rent, insurance, all my other depreciation, all my other fixed costs associated with having this new facility. All right, so if my fixed costs went up by $30,000, I want to see how that impacts break even. All right, I can do that again. 100x, all right, my selling price didn't change, right? 70x, my variable cost didn't change. My change here is an increase of $30,000 in fixed costs. So instead of $90,000, I now have $120,000 in fixed costs. I'll still set this equation equal to 0. All right, I'll combine my x's. I have 30x equal to, I'll add $120,000 to each side, so equal to 120,000. All right, I can do that math over here. I can probably do that one in my head, but it's all right. So 120,000 divided by 30 tells me I now have to sell 4,000 units to be able to break even. All right, so because of that $30,000 increase in fixed costs, I now have to sell an additional 1,000 units to be able to break even here for Lewis and Tom. All right, so that is how we prepare something, one more time, called sensitivity analysis. All right, now there's one more application of, or one more piece of sensitivity analysis that we haven't seen yet, and that's this one right here. It's called margin of safety. So the margin of safety basically just wants to know how much wiggle room do I have? All right, how much can I screw up my calculations here and still be okay? So the margin of safety is the excess of my expected sales, how much I expect to sell, over my break-even sales, how much I need to sell to make sure that I'm not losing income, losing money here. All right, or if I want to think of it, over doesn't mean divided by, just a heads up. If I wanted to think about it as a formula, it would just look like this. My expected sales minus my break-even sales. Expected minus break-even, that tells me how much my margin of safety is. All right, so let's navigate back to Excel over here, and let's see how this would look for Lewis and Tom here. I have a couple of margin of safety, so let me get rid of some extra cells in here now. A couple of margin of safety questions for me over here. All right, because margin of safety could really be presented to you in one of two ways here. It could be presented as an expected sales number, which makes it nice and easy, which is what letter A does right here, or as an expected operating income, which just adds a little bit of a twist here. So if it was asked to me as an expected sales number, remember what I said my formula was for margin of safety is just how much is expected sales over break-even sales. All right, well, I have both of those inputs already for letter A here. I know my expected sales right here. It says, what is margin of safety if Lewis and Tom expect sales of 750,000? All right, well, there's my expected sales, 750,000. It's how much more are those than the break-even sales, right? Again, I know my break-even sales. I just calculated them right here as 300,000. So 750,000 minus 300,000 tells me margin of safety for letter A here would just be $450,000. All right, their margin of safety, that's the wiggle room that they have, how much they can mess up by and still be okay. All right, well, let's look at it. Let's look at it for letter B here when they give me operating income instead of expected sales. So if I'm given operating income, that means I don't know what my expected sales are, right? So I can't just take 150,000 and subtract 300,000 from it and say my margin of safety is 150. That doesn't work because the number that I have here, I don't have like terms here, right? I don't have two numbers that I can compare. Right now I know what my break-even sales are. I know one piece of that formula, but as of right now I don't know my expected sales. I know my expected operating income. But we could take that expected operating income and then we could back into what expected sales are. We just learned how to do that actually. We could do it with our formula here. All right, so let me see, 100x minus 70x minus 90,000 equals, all right, I'm saying that I'm expecting my income to be 150,000. So I'll just set my equation equal to 150. All right, same approach we've taken before, combine my x's. I have 30x equal to, add 90,000 to each side, so 150 plus 90 equals 240,000. Do some math right here. 240,000 divided by 30 tells me that I have to sell 8,000 units to be able to break even. 8,000 units to be able to break even, right? So I can see already that my break even in units, which isn't what I'm really looking for yet, just a heads up, right? But my break even in units would be 5,000. All right, not my break even, sorry, my margin of safety. All right, so because I'm expecting 8,000 unit sales at 150 and my break even units were 300,000, but it wants a dollar value. So let's take this a step further. All right, so 8,000 units. I'm going to multiply that by my selling price per unit of $100. So 8,000 times $100. All right, that gives me, so make this a dollar amount, get rid of some decimals here. That gives me $800,000. $800,000 of expected sales at that income of 150,000. All right, that means my margin of safety, I'm now ready to figure this out. I now know my expected sales are 800,000. My break-even sales were 300,000. All right, so 800,000 minus 300,000 gives me this margin of safety here of $500,000. All right, hopefully you've enjoyed video number 1 here. I'm going to come back and work through some exercises just to illustrate some more of this cost, volume, profit analysis in one moment.